Welcome to Simple Block Studios. We are a team of 2 people who have decided to work on our own indie games. Our first project is a space game. We are yet to decide on the name of it as of making of this dev blog. However, the name of it will be in the title of the video once we upload this dev blog. Here I got a notepad file going over what we're going to talk about today, starting with our sprites. For here we have a ship. This is what we intend the starting fighter to look like. If we open up here, we have 2 parts of the sprite. We have the body and the team color. The body is not intended to change color, but the option is there if we so choose. And the team color can be anything. I just have it defaulted to a blue color because I like blue. The color itself doesn't matter a whole lot, but next on our list, thought process behind the sprites. Okay, here we have, let me show them real quick. We have our RCS thrusters. Here, then all of these. Then the main engine plume, where that one's not finalized. But this big cube here, that's intended to be a fuel tank. These ships are using hydrogen and oxygen fuel, which, even though this game is going to be set pretty far into the future, not like tens of thousands of years or anything, but still pretty far out, so they're still using hydrogen for their smaller ships. And due to that, the ISP is going to be higher than modern day stuff, but not by a whole lot. Most of the fighters still going to be fuel tank. There are also pipes in the hull that lead up to the RCS thrusters. Now, RCS thrusters are lower efficiency, smaller thrusters that are put on the side of the ship for general maneuvering and turning. As you can see here, if we turn this on, this is the RCS plumes that point the ship, that push the ship backwards. These ones pull it forwards. I'm sure a lot of you are familiar with this, but 2 sets of RCS thrusters are required to turn the ship, because if you only have 1 thruster, it will turn it and push it. So you have 1 set that pushes it down, and this one that pushes it up, and that puts a torque on the ship and rotates it. In this case, it's going to be, it's going to be this way. Other set is going to push it not this way. And having those 2 thrusters there lets it go, not that way, this way. And having the 2 bottom ones will make it go up relative to world space. Over here is the cockpit and guns. Here's one of them, here's the other. This is where the pilot would sit. These team colors are not lore accurate. They wouldn't be these colors. These are just for the player to know what they're actually looking at. Ship AI behavior. I'll go ahead and scroll out, and over here we have a second ship. For demonstration purposes, I'm going to turn off its AI scene, and over here, as you can see, it should be pulling up here. Yeah. Currently, let me pause it real quick. Currently, what the AI here is doing is it thinks it's pretty far away from the enemy ship here. Currently, it doesn't have a targeting for it, but so it's manually set to think that that's the enemy. Over here, it's engagement range. Where is it? Here, 20. That's 20 units away. I think it's going to end up being meters. It thinks it's currently too close to really use its main thruster. The thrust acceleration here is, all these numbers are smaller than they're going to be. Yeah, this is all just for testing reasons to make sure the numbers work at a really small scale. Since if they don't work at small scales, they're not going to work when they're scaled way up, and you won't be able to tell what's going on at big numbers. It's currently at about 50 meters away from its target, and the ship isn't comfortable using its main thruster to get to the ship, but it is comfortable using it to stop once it reaches the enemy ship. So it's using its RCS thrusters, build up speed to get to the ship here. So I'm going to unpause, and we'll see it's adjusting for movements and turning and stuff. Once it reaches engagement range, as you can see, that's a visual bug. I'm going to have to figure that out. It is currently turning, getting closer to the ship, and then going up. We'll see what that looks like here pretty soon. If I could go into scene view. You can see it's trying to get to a specific point. I don't have it displayed here, I think. Okay, that's the point relative to the target that it's trying to get to. It adds this to this, and that number is its speed along this direction of the ship here. And as it goes up, you can see it's anyway, as you can see, it picks a point and it uses its RCS thrusters to go to that point, which I think it's about there, I think. About over here. Scene view. Last thing before we get to the technical side of things, we're gonna go over the armor and hull system. Now, all projectiles are going to do some damage to the hull. This is so that you can't just damage tank your way to victory. You will eventually run out of armor, and all that damage is going to go to your hull. There will be no way to repair armor during a mission. So once your ship is out of armor, it's best to pull it out so you don't lose it. They can repair the hull during a mission. It is 378 lines of code for the entire ship. We're going to start at the very top here. I haven't commented at all, but I'll explain as we go. Here we have a list of the game objects that the ship is using. This one's the ship. It's starfighters, the ship itself. The gun is the gun. All these are the RCS plumes, and this is the plume of the main thruster. All of this is just visual. This is a developer tool. All the print commands will be in here, so all the print commands can be turned off by turning the printing on the ship off, so that you're debugging a specific ship. And over here are the other scripts that the ship uses. This is the part manager. This contains the HP bars of the ship. This is the fuel tank where the fuel is stored. This is the fuel cell. Fuel cells generate electricity by burning fuel. It's something the Apollo missions used. This is the battery. Self-explanatory, it's a battery. The blaster, this is the gun. Because this was named gun, I couldn't use the name gun for the script as well, so I called it blaster. And it's kinetic because we're shooting projectiles. This is the rigid body of the ship. It contains the velocity, speed, mass of the ship. These three are variables that the player is going to be able to set. This is how fast the ship will go when getting to a target. This is how fast the ship will go when it's close to its target. And this is how it decides. This number decides what close is. This one's how the ship accelerates using its main thruster. This is how much fuel it uses per second. RCS is the same, but for the RCS thrusters. Turn rate is how fast the ship can turn. It's currently set to 100 degrees per second. This is how much energy it uses to turn. And this is the target the ship is at. This is going to be set to private later, but it's public for debugging reasons. This is an internal timer variable. This is a internal RCS variable, so that in case if it calls the RCS adjustments multiple times, it only fires it once. And this is where the ship will attempt to be going to later. In the start, we just get all the script components. I might move some other things over there too, but for now that's all up there. All of these functions are the same thing, but for different directions. It will, if this is called, it will turn on the thruster group and turn them on, and then apply force in the direction in question. I haven't finished commenting yet though. This is the code that sets where the ship will go to when it's gonna go for a specific point. I'm going to rename that at some point because this is for combat. We will pick a random spot within a circle with a radius of 1 and then multiply that by the engagement range and return that number back to the code that called it. Over here, we set the RCS to false so that it knows that This is a new tick. We add timer to delta time, and every 5 seconds reset where it's going to go to. Here turns off the RCS plumes, since the RCS plumes can be called multiple times. And down here we have a check to make sure the target's not null, and that the ship has energy to use. If the ship runs out of energy, all of this code stops. Defaults onto the amount of degrees that it will attempt to turn by to 0. This defaults the aim here where the ship's going to be pointing at to 0. All of these are just directions and position variables that are used to calculate various things later. Here we have the world velocity of the ship, the relative position of the ship, the speed as a vector 2 of the ship, and the relative velocity of the ship to the target. I won't explain dot product here. If you want to know what a dot product is, you can look it up. Just know it has to do with circles. Here we get the dot product. That should be a vector 2. Of the velocity relative to the relative position, direction we want to go, and the linear velocity, the direction it is going. And the dot product is going to be the difference of the two. This is the absolute relative velocity. It's just how fast the ship is moving relative to its target. This is the distance between the ship and the target, and this is the distance from the ship to the target. Down here, we default the speed that the ship will be attempting to move at to the cruise speed. And if it's within engagement range, we will instead... This number is used for calculations to figure out where it needs to aim to land its shots. I don't actually understand the quadratic formula. As you can see here, where is it? Yeah. Now, I used AI to figure out the math here. I know it's the quadratic formula, but I don't understand it. If you guys do understand it, let me know. What I do understand is that the ship moving through space means that we have to aim where it's going to be and not where it is to land any shots. When we're talking about thousands of meters out, just pointing at the enemy ships, it's not going to land any shots. Maybe hundreds of meters shots would still land, but not thousands. Not tens of thousands. We aim where the ship is going to be in a set amount of time instead of where it's going to be. Over here, you have two dot products, one for the angle the ship is at and one for the side of the ship. These two are used to point the ship, and these two are used to move the ship. It technically doesn't need it to be in degrees, but for convenience on my end, I converted it into the dot products into degrees later. Over here, if the ship thinks it's close to its target, which here it is 60 plus the amount of time it'll take to turn, it will flip the dot side and dot angle to be pointing away from the ship and not towards, so that the main thruster is ready to stop the ship. Over here, if the ship is close, it will check if it's near where it's wanting to be. This line gets the distance from the relative position to where it wants to go, and if it's close to it, it'll find a new spot to go to. This is so that the ship isn't just going in a straight line towards the ship, so that there's at least a chance that it'll dodge. It's not actively trying to dodge, though. We convert the angle that it's at into an angle in degrees, and default turn by the turn rate. If the dot side is greater than 0, this is needed to know which side the ship is on. So the dot side is relative to this, and if we have a dot angle here, it's 1 here, it's about 0.7 here, 0 here, -1 and whatnot, but it's also 0.7 here, 0, -0.7 and -1 here on the circle here. I'll probably edit in the visual. And so it'll say, when converted to degrees, it'll say 30 here and 30 here, and so we have a dot side so that it knows that this is -30 and this is +30, and it can adjust for that. Makes it a negative number, so it turns around. Almost every line from here on makes sure so that the ship is close to where it's supposed to be pointing at, and if it's pointed away from the ship, it will align the thrust, but also account for the fact that the ship's turned the other way. It'll invert the direction the thrust is going in, and if it is pointed towards the ship, it will instead not account for that and just align thrust. If it is close but not quite aligned, it will slow down the rate at which it turns so that it's nice and smooth, so that things are stuttering and fixed weapons can land properly. Over here, if it's really far away, it will turn on its main thruster and add force in that direction. If it's close, it will account for the amount of stopping distance it has and move to a speed that its RCS thrusters can handle right at the edge of its engagement range. Here, it will take energy from the battery at the rate of its energy uses per second, based on the amount of space it turned, and it will then apply that rotation to the ship. All called down here is just visuals. These don't do anything for the ship itself. This just tells it which set of RCS thrusters to have on. If the angle is greater than 30 degrees, it will have RCS towards the point, and if it's close to but quite aligned, it will instead have the RCS thrusters active, slow down the ship from a turn. This here is the aligned thrust thing. I'm still working on this. It's not quite finished, but the gist of it is it will take the speed the ship is going, check along a circle how fast it needs to be going in that particular direction in local space, and apply thrust in that particular direction. I'm gonna go to the projectile script here and go over how armor and hull works. Every projectile, unlike in most games, will penetrate armor by a little bit. Likely at a minimum, it's going to be 10%. I have it set to 40% on the starter ship right now, but that's subject to change. And so some damage will always make it to the hull. Projectiles do account for which team they're on. It's implied that friendly fire is on. It's just using the third dimension to not hit friendlies. Here it'll check when it hits something, and it'll get the part manager of what it hit. If the part manager is a real thing, it will then set the hull damage to damage, and if there is armor, to take damage. If the armor is lower than the amount of damage the armor would take, it will go straight to the hull, and if not, it will do damage proportional to the armor penetration straight to the hull. Here it sets the armor to the damage minus the hull damage, because this is the amount of damage going to the hull, and it will do hull damage equal to the amount of damage that it's set to go to the hull, then destroys the projectile. That's it for this dev blog. If you got any suggestions, ideas, or thoughts, leave them in the comments below. If you'd like to play this game, leave a like and subscribe so that there's more people to see our work, and we'll buy our game when it comes time for releasing it. We thank you for watching, and goodbye.